Hello everyone. So today I'm going to discuss my project which is on real-time wireless sensor network using CC1350 dev kit and sensor tag with an ESP32. So here I have implemented single hop and multi-hop architecture with WebSocket dashboard. So introduction to my project. This project details the creation of real-time wireless sensing system leveraging the CC1350 dev kit and ESP32 for robust data collection and visualization. Here we aim to explore different network architecture that are multi-hop and single hop network. In single hop network we are using direct UDP communication, and in multi-hop network the RPL based routing for extended range is used. So at last we will display these data using WebSocket for the real-time data visualization and interaction. So going to the architecture part, we have a sensor tag which will collect data from environment. Then that data will be sent to the LaunchPad by UDP communication, which is CC1350-4 LaunchPad, which is acting here as a main gateway. And then from serial communication, this data will be transferred to the ESP32, which will act as WebSocket server, forwarding part sensor data from the LaunchPad to connected browser in real time. Then ESP32 receives the serial data from the gateway and broadcast it to the client via WebSocket. And finally, the data will be displayed in the web server of the client. So here the hardware and the tools which will be required here are like first is the CC1350 sensor tag, which is used here, and the CC1350 launchpad or development kit. Then again we will be requiring an external microcontroller, which is here is ESP32 Room 32, which is powerful Bluetooth and Wi-Fi microcontroller here. So coming to the software tool, we are going to use Contiki-NG, an open source operating system for IoT device providing network stack. Another thing is UniFlash, which will be a Texas Instrument tool for flashing firmware to CC1350 devices. And the third software which will be required here is Arduino IDE for ESP32 programming, which will be useful in hosting web server and all. So moving to the features of CC1350 sensor tag. So the sensor tag is manufactured by Texas Instruments already, and it supports dual band. Dual band, it means like sub 1 gigahertz, the frequencies which are less than 1 gigahertz, and the frequencies of 2.4 gigahertz, that is Bluetooth low energy frequencies, it is also supported in these sensor tags. We are using HDC 1000 sensor, which is embedded in this sensor tag, which is used for temperature and humidity. Similarly, this sensor tag has multiple sensors like light sensor, pressure sensor, which can be utilized in some other project also. The power supply of this sensor is from coin cell. We can use coin cell or we can use the USB cable. I have used USB cable in this. So moving to the another product which we are using here is CC1350 launchpad. It is also the dual band supporting device like sub 1 gigahertz and 2.4 gigahertz. Again, the power thing is the powering of this board is with USB cable, and connectivity is from USB for serial communication with PC. So role in this project is like in single hop it acts as UDP gateway, relay sensor data to ESP32, and in multi hop launchpad 1 is configured as RPL root, and launchpad 2 works as RPL router slash forwarder. So in software tool we have Contiki-NG, which is very good tool for for setting environment, which can be good for, which is very helpful in using this software of Texas Instrument, which is open source here. So moving to the single hop network which I have developed here is like this. Here we have a launch pad connected to this PC for power, and similarly a sensor tag is also connected to the PC, and their codes are flashed respectively. This sensor tag sends data from the environment and send that data by a UDP connection to launchpad, and that launchpad is now connected with an ESP32, which will be projecting data to WebSocket. Similarly, in multi-hop network, we have two launchpad. One launchpad is acting as a main gateway. The another launchpad is acting as a forwarder. The one sensor tag, this sensor tag A, is connected to this launchpad A directly, while the other two sensor tag B and C are far from launchpad which is acting as main gateway. So it cannot be directly connected to this main gateway. So it will use this forwarder launchpad as an intermediate through which it will be connected to the main gateway. And finally, after connecting with an ESP32, a web server will be hosted where the temperature data which is used in this project will be shown. like this. In the single hop network, we will be having this kind of dashboard where the temperature data is shown, and in multi-hop network, this kind of dashboard will be there where multiple node sensor data will be shown. As an output analysis, we get a very good output. There is very less latency, 50 to 100 milliseconds only from the sensor reading to the dashboard display. And it is very good, minimal data losses there. We are getting the exact reading which is in the temperature, and the sensor is also collecting the same kind of data. So no issues are there. So moving to our hardware demonstration, I am going to demonstrate the project. So this is my single hop network project where I have connected an LaunchPad with ESP32 through an cable, like female to female cable, where the D16 pin is connected to transmission pin of this LaunchPad, and LaunchPad is connected to SensorTag. Here, this is the code from where we will be using which we are going to flash on ESP32, and we have entered the Wi-Fi credentials here, and the HTML and CSS file is embedded in it. Here we can see that it is successfully booted here, and the output is coming in serial monitor. Now, by using the ESP IP address, we are going to access it in web browser. So we are going to just copy the HTTP link which will be mentioned here. Let's see where it is. Yeah, now. So we are going to paste this in the web browser, and from there we can see the real time monitoring of this temperature which is accessible on the data is loading right now, which is going to fetch from the sensor, and here it is. So this will be the real thing. So this is my multi-hop wireless sensor network here. This is LaunchPad which will be acting as a forwarder, and this is the LaunchPad which will be acting as main gateway. This is ESP32, again used for serial communication, like from where the WebSocket can be connected, and here again D16 pin is connected to transmission pin. And this is sensor tag A directly connected to LaunchPad 1 which is acting as main gateway, and we have another LaunchPad also. So this is the code for ESP32 which has been flashed, and output is coming successfully, and again we are going to run this on an IP address. So let copy the IP address and paste it in the web browser. So here now again the waiting time is there, some delay like latencies, and now the temperature is again coming up from every node. Thank you.